Hey ho! Can you see the difference between these balloons? It's obvious, isn't it? The one on the left is filled with ideal gas. Huh? You can't see it? Okay, then we'll have to look a little more closely. Let's go! So, an ideal gas. What exactly is that? As the name already tells us, we're dealing with an idealization. Idealizations in science are just simplifications that make it easier for us to do the calculations. For example, we might pretend that something that is nearly circular is just a circle. If we have something really squiggly, it's difficult for us to determine the area and the perimeter. With an idealization, it gets much easier, and the results are pretty much the same. So, real gases are a lot more complicated than ideal gases, and calculations for real gases can get very messy. That raises the question, what should we simplify for a real gas? Of course, you already know real gases, right? Normal air, for example. If you look closely at air, you'll see that it consists of different atoms, quite apart from the dust and dirt in the air. Now, these atoms consist of electrons, protons, and neutrons. The electrons spin like crazy, which causes electromagnetic interactions. The atoms occupy a certain space, they attract each other, they repel each other, blah blah blah. For an ideal gas, all these annoying details are just ignored without further ado. Ideal gases don't consist of three-dimensional atoms, but just of zero-dimensional points of mass. And these particles move undisturbed through space. Undisturbed means that they just fly straight ahead until they bump into the wall or into another particle. And then, if these little guys meet another particle at any point, they just bump into each other like billiard balls. So, the collisions are perfectly elastic. That means that particles don't slap into the walls like a lump of dough, but bounce off completely undeformed. They also do the same when they bump into one another. And that's it. These simplifications or idealizations lead us to a really awesome equation, which makes calculations for an ideal gas a piece of cake. And that is the so-called ideal gas equation, also known as the thermal equation of state. It looks just like this, and it is incredibly important. If you want to find out more about that, you should take a look at our video about it below. Now let's put all of that back together. Ideal gases are just a simplification of reality to help simplify our calculations. The important simplifications are that these particles of gas are only point masses with no spatial extent, and that the collisions are perfectly elastic. Otherwise, the things fly straight ahead with a constant speed until something happens. So, good work, guys! We hope you enjoyed it. If you're still up for some more, we'll see you in the next video. Catch you later!